10.6, we're talking about segment lengths. So we've been talking a lot about angles, and now this is about segment lengths. In the figure shown, PS is a tangent segment, okay? Because it is tangent to the circle at an endpoint. PR is a secant segment because one of the two intersecting points with the circle is an endpoint. And PQ is the external segment of PR. Do you see how PQ is on the outside of the circle?
Yeah.
Therefore, it's external. Okay. Theorem 10.14. If two chords intersect in the interior of a circle, then the product of the length of the segments of one chord is equal to the product of the length of the segments of the other chord. And I will, right below, there's a diagram for each one that I will explain.
Right.
10.15. If two segments share the same endpoint outside of a circle, then the product of the length of one secant segment and the length of its external segment equals the product of the length of the other secant segment and the length of its internal segment. So it's a lot of stuff. Hold on. The diagram's going to make so much more sense. 10.16. If a secant segment and a tangent segment share an endpoint outside of a circle, then the product of the length of the secant segment and the length of its external segment equals the square of the length of the tangent segment. So that sounds like a lot of words that we don't understand. So let's look at the diagram. Okay. So everybody sees A to E. A to E times E to G, E to C equals B to E times E to D. Okay, pretty simple statement. All it's saying is this segment times this segment equals this segment times this segment.
It's all work.
It's really just multiplication. All right.
Too much fun.
The next one, do you see how we have two secants? Okay. If we take A to C and multiply that by B to C, just the outside part, it equals D to C times E to C. So it's the whole thing times the outside equals the whole thing times the outside. Okay. So now we've got a secant and a tangent. So we take A to C times B to C equals DC squared. Yep. Now we're just going to go through and do examples of these. I think they're pretty easy. Okay. So for A, we simply go 4 times 4 equals 5 times x. So 16 equals 5x. Divide by 5. X equals 3 1/5. None. All right, how would I set up B? 3 times 8 equals 2 times 3x. 3 times 8 is 24, which equals 6x. Divide both sides by 6. X equals. All right. Let's do the next one. 4 times 13 equals x times x. What's x times x?
X squared.
So we get 52 equals x squared. How do we get rid of the little squared? Square root. So we get x equals the square root of 52. I don't know what that is off the top of my head, but that could be the right answer. Any questions about finding the length of segment chords? All right, let's turn it over. All right, this is going to disappear apparently. Is x is the square root of 52. You can figure out an exact answer if that helps. Okay, we're looking at example 2. So I'm going to set up the first one for you. We take the length of the whole thing of the secant. So 6 multiply it by the external part, which is 4, and that's equal to the whole thing, which would be 5 plus x. No, I did not. Times the external part, which is 5.
What is
Okay.
that? And inside 5.
5 plus x. Let me write it again. Because it's the whole thing times 5. So 10 times 4 is 40. And we're just going to distribute. We get 25 plus 5x. Then we subtract 25 from both sides. And we get 15 equals 5x. Divide by 5, x equals 3. Somebody want to set up b for me? How would I do it? So you'd have 4 plus,
Oh, B.
okay, so you'd have 4 plus x times, okay, equals 9 times 5. So we get 16 plus 4x equals 45. Subtract 16 and we get 4x equals 29. So x equals 4 goes into 29 7 times with 1 left over. 7 and 1/4. How are we feeling about this? Chance. Round back. Okay. Let's do C. Write this down, Chance. We're going to do 1 plus 2x times 1, right? Because that's what's on the outside. Equals 1 plus 4 is 5 times what's on the outside? 1. So we get 1 plus 2x equals 5. So 2x equals 4. So x equals 2. I know I do the algebra part pretty fast. If you're getting lost, please let me know. Uh-huh. Because I did 4 plus 1 because I wanted the length of the whole thing. So you guys feel like you could find the length of segments that are secants? Okay, let's do a secant and a tangent. So we've got to do the whole thing, which is 13, times the outside part. I'm just doing b. There is no a. Equals 2x squared. So we get 117 equals 4x squared. Divide by 4. Because 2x times 2x is 4x squared.
That one might get rid of the squared.
Because x times x is x squared. So I got 2 of these, Chris. I got 2x times 2x. So 2 times 2 gives me 4. X times x gives me x squared. Okay. All right, divide by 4, and we get 29.25 equals x squared, and then we have to square root both sides. So I just like leaving it as square root of 29.25. You can figure out the decimal equivalent though.
We can mark that into whether it's a square root of that.
Okay, how are we going to do the next one? Okay, so we're going to do 12 plus 4, which is, and then we have to multiply what's on the outside. Equals x squared. So 12 times 16 is what? Apparently I didn't solve that. 12 times 16 is 192. Equals x squared, and then we take the square root of both sides. Does this come up nicely? Probably not.
13.8.
Alright, so we can just leave it as the square root of 92. That's fine. Any questions? I think this was a lot easier than yesterday's stuff.
Oh, yeah, definitely.
Yes, Brian? Because you have to square the tangent. That's the formula from back on the other page. If you flip your paper over, we're looking at the third diagram at the top. and we have to square the tangent and set it equal to the length of the secant times the external part of the secant. All right, ladies and gentlemen,